Thank you all for being here today. My talk has several provocative statements, and I'm hoping that they will cause you to go berserk. Our goal is to think about the Internet of Things as it is perceived by consumers. So we're not trying to solve the problem of the smart power grid or oil rigs offshore. We're really focusing on use cases for you and I. We think of these systems as an evolution of web search, right? People want information, people ask for it, people get information. These days, these web search systems, they are evolving into question and answering systems. So you talk to your Apple Siri or you talk to your Amazon Echo, you make requests, you get replies. We want to generalize this concept for not only knowledge that is up there on the web, but also knowledge that is being generated and actions that are available around you in the Internet of Things. Your lights, your temperature, your coffee, right? So we're thinking of these systems as stimulus response systems, where the stimulus can be you enter a room, and the room does something. You touch a button, and as a result, lights come on. But which color do the lights have? Maybe I prefer red, maybe my wife prefers blue. I need a coffee. I like black coffee. The coffee machine should know that. My wife drinks cappuccino. The coffee machine should know that. We should not have to fiddle with controls. Our house should know our preferences and react accordingly. Moreover, this personalization should be available everywhere. I've never been to this hotel. I walk into the lobby, there's a coffee machine. I need a coffee. The coffee comes the way I like. The coffee machine instantly acquires the knowledge about how I like my coffee and pours it for me. How is this possible? Well, today it's being made possible by pumping raw data to the cloud. Everything that we can learn, everything that we sense is being pumped to the cloud. This is the Internet of Things by default, the way that everybody is doing. I'm going to argue that this leads into three very serious problems: responsiveness, fragmentation, and loss of privacy. So I really don't mean to pick on Wink or Chamberlain garage doors. This is an actual screenshot that was captured in November 2014. And it says that in such a date, such a time, the servers will be going down for maintenance. So don't plan on opening your garage door from your app for 4 hours, right? I mean, I really don't want to pick on them. This can happen to anyone, but it's an example that you lose your servers, you lose your connectivity to the cloud, your smart home is no longer smart. Multivendor fragmentation, reality check. You buy a Bosch dishwasher, it wants to connect to the Bosch cloud. Buy a Philips Hue light bulb, wants to connect to Philips. Buy a BMW, wants to connect to the BMW. Now, the business models of these companies, they are centered on the value of data about their consumers. Data became a business asset. They will not willingly share that. So for you as a consumer, you end up not with one smart home. You'll end up with 50 different systems that talk to each other the least they can get away with, right? Because there's business behind their knowledge. There's value. Speaking of data, we have, of course, data that is meant to be shared. Public domain data, what's the weather like? What's the traffic like? Corporate data, what products do I have? My owner, my product manuals, and so forth. There's data that I mean to share as an individual, my social network, pictures that I want to put on Facebook. But there's also data about stuff that I own. Data that's being generated by my appliances in my smart home. Data that is being generated by my car. How fast am I driving, right? This data is now being increasingly used by companies for managing their resources better, helping us manage energy better, helping us with predictive maintenance. All of that is great. But increasingly, there's also data being gathered about you. How well did you sleep? What are you doing? What are you saying? So not all of this data is created equal, but it all goes to the cloud. What does that mean to you? Let's look at some real products out there on the market today. We all know Nest, the thermostat. It has a motion detector, which means that now Google knows whenever somebody's at home. Amazon Echo, it sits on your kitchen, you talk to it. Speech processing is being done in your cloud. Amazon now is listening to what you say. Jabra has earbuds that have a sensor on pressure to detect heartbeat and help you optimize your exercise. Well, heartbeat can also tell whether or not you're nervous, whether or not you're telling the truth. Sleep Number, one of the largest manufacturers of mattresses in the US, has a nice product that goes on your bedside table and detects snoring. And coupled with an advanced mattress, tosses you over so that you don't wake up your spouse. Right? It also responds to voice commands. Raise my feet, lower my head. Speech and snoring detection in the cloud. Now Sleep Number knows everything that goes on in your bed. Toto, a very large manufacturer of toilets in Japan, does real-time analysis of bodily fluids to help you control situations like diabetes. Imagine you wake up one morning and your toilet turns to you and says, Bob, you drank a lot last night. And did your doctor really prescribe these drugs? So the Internet of Things has this creeping factor that not only it senses everything around you, everything you say, everything you see, but increasingly also everything inside your body. So there are no boundaries for the Internet of Things. And we're putting all of this data up there. So if that bothers you, it bothers us as well. And Bezirk is about reclaiming boundaries. Bezirk is about putting on the cloud what we mean to share and keeping local what we would like to keep within our sphere of trust. So we're keeping data local, and we're changing the nature of the connections to the cloud. Data goes up what I, as a stakeholder in my environment, am comfortable sharing with the cloud. If my dishwasher knows that he's going to run into trouble and wants to contact Bosch to do predictive maintenance, maybe I'm okay with that. I would like to have a choice. Maybe I'm the first person that the dishwasher asks, say, hey, I think I see a problem. Is it okay for me to contact Bosch? And I should have a choice. And if my bed detects that some activity went on there, and I'm not going to specify what, that should be a conversation between my bed and I. Right? So we're reclaiming these confidentiality boundaries with a security model that is based on users, allowing users to define spheres of trust, and everything that goes on inside the sphere stays inside the sphere, and defining pipes, which are controlled channels to the outside, where users may define policies of what is allowed to travel in and out of your sphere of trust. In addition to these confidentiality boundaries, spheres also provide for naturally topology boundaries. If you think about it, the successful applications on the internet involved primarily remote communication, email, web browsing. Everything was remote to a remote server. In the IoT, that's not the case. The vast majority of the communication is local, is inside your car, is inside your home. Your thermostat wants to talk to your furnace. Your light switch wants to talk to the lights. Your phone wants to talk to everything while you're in the house. How often do you turn off the lights when you're at home when you are at the office? A lot fewer times than when you are right there at home, right? So most of the communications are indeed local. Our claim is that IoT topologies should recognize and support two kinds of communications, local and remote. And the addressing of communications should reflect that, which means that you don't really need a unique Internet worldwide identifier for every one of the thousands of sensors that are soon going to be in your house and that your car already has. It's enough for you to identify uniquely your car as a unit or your home as a unit. Once you get there, then you can use different mechanisms. And the mechanisms that we're using for local communication is publish subscribe, brokerless publish subscribe, specifically an open source software called ZeroMQ. On top of that, we're building our security model with spheres and pipes, putting addressing by intention on top of it, so that you, as an application writer, you don't have to worry about what devices are out there. You can address all the lights in the kitchen, right? You don't have to know the MAC addresses of all of them, addressing by intention. And on top of that, we want to support multi-vendor operation with interoperation protocols. And then applications are built on top of that line. And one class of applications that we are especially interested in is exactly building this personalized experience where we promote decentralization of knowledge. My phone learns about how I like my lights, my temperature, my coffee. My wife's phone learns about how she likes her stuff. And each of us holds knowledge. Now that knowledge, it travels with me over there. Anywhere I go, my phone says, hey, I have a user. Notice that my phone needs not reveal my identity. I have a user. The environment replies, OK, I'm a thermostat. How does your user like temperature? I'm a coffee machine. How does your user like coffee? Is he ready for a coffee? And my phone replies only with the necessary information to personalize my environment without having to reveal who I am. Right? So if you're curious about these protocols, we have a spec of these protocols that enable exactly learning how I interact. So this personalization does not have to be programmed. It's learned by the ways that I naturally interact with the environment. We have protocols that enable exactly devices to say, how does your user like your coffee? So all of that is laid out. We're building these protocols on work by the semantic web. So we're reusing the wheel whenever it's possible. And these protocols are built on rich forms of request reply. We're not bound by the classic unicast request reply. We can have group request reply. For example, hey, I'm here, I need service, and whoever is out there that thinks has a service can then unicast a reply. So the middleware supports that. We are opening up the middleware. If you'd like to check it out, go to bezirk.com. We are hosting the SDK and the documentation up there. You are free to download the binaries, to look at the documentation, experiment with it. In addition to middleware, we have some goodies for you to download, like free indoors localization based on Wi-Fi fingerprinting, or even this personalization technology. So you can experiment with it, build your own components, build your own use cases, and just experiment with it. So right now, we have Java implementation that runs on Android, and of course, Windows and Linux. We're planning on having soon iOS version as well. And I will be glad to answer questions.
Thank you, João. I'm sure there will be some questions.
So one of the things that the cloud promises is that I can get access to my data wherever I am.
Yeah.
And one of the added values of that is that if I lose my phone, or if I go and visit a friend and use his computer, I can have access to that data. So
Excellent question.
I obviously expect my data to be encapsulated in something that is quite secured. This seems to be the other case, right?
Yeah, we're going in a different direction. So what bothers us is that the data goes to the cloud unencrypted for processing and for analytics and for chopping and selling. So the minute that data goes to the cloud, it no longer belongs to me. It belongs to the company that hosts that data. We're saying, well, cloud is not necessarily evil. It's not just a hammer for whole nails, right? So if you want to back up your data in the cloud, by all means, encrypt it, right? So the cloud does nothing with it except saving it for you. You lose your phone, you download it to your new phone. No problem, right? We have that.
Last question.
A lot of devices pumping data to the cloud, personal data, and I like the approach. I'm just wondering if the classification, what information is public, what's in your sphere of trust, does it follow a convention over configuration model, or could it be troublesome for the regular user to classify information?
That's a great question. So will users be able to wrap their heads around this conceptual model? We are hoping that they can. we're hoping that these will reflect natural boundaries and natural exchanges. For example, in this picture here, you see two spheres. One is the home systems, the other one is home entertainment. So you're allowed, you're of course more than welcome to define as many spheres as you want. We don't expect people to go crazy with spheres. But if you have at least two, that will enable you to open up the home entertainment sphere for your friends when they come over. But you don't necessarily want to give them access to everything in your home, like the surveillance system and everything else, right? On the other hand, say that one of your spheres has medical devices because they have a health condition. You may want to create a pipe to your doctor and say in that pipe, if there is an alarm or a situation of concern raised by my health devices, I would like my doctor to know instantly. So the policy on that pipe says my doctor can know situations of concern with respect to my health. Nothing else. So that's the policy that you associate with the pipes. We hope that people can get their heads around this. Yeah.
Thank you very much, João.
My pleasure.